So welcome all. This is the course on the deep learning, and as you know that I am Dr. Kamlesh Tiwari. I am offering this course from BITS-Pilani campus. In this session, this is the first class. I welcome all of you, and in this session, we are going to talk about something that how we are going to run this course means we are going to talk about the logistic of this particular course, and we are going to see the introduction of related to this particular course. That what is the background and how the things are. There what are the things, what are the important things are there into this particular domain. My objective in this particular course is going to be to give you the very high level, not only the very high level intuition of the things, but also the mathematical and their relevance into the practical domain. This course is going to be a practically oriented course where you would be learning a lot, and that's why the things that are going to come into this course are actually planned. So let me start by introducing you this particular website that actually we have set as a course website, and this is the ktiwari.in/dl. So let me try to open this website once for me. So this is a website, and this is the page that you can go over there. Um, am I on the right page? Okay, no, I think I'm not. So it is going to be, the website is going to be ktiwari.in/dl. So you just click on this ktiwari.in/dl. This is the website that you can get. This is the course web page that we are going to follow. Here you can find out some information such as what is the lecture schedule, link to join the live sessions, etc. And you can see that there is a no prerequisite of this particular course. Course handout is also being updated at this particular place. You can see over there. And if you click on the lectures place, here you can see that the lecture number 1 and today's date, and you can see that what is going to be into this session, and there is a PDF available. If you click on this particular PDF, you would be getting uh, a document where all the slides that we are going to discuss today would be available over here. So what I ask you that every day, that whenever the class is going to start, before starting the class, this particular slide would be definitely available to you. Not before, I think, 1 hour, because I keep updating the slides, and before 1 hour I regularly update this thing, so that whenever you come to the class, you are prepared with the questions that are there. So take advantage of this thing. Second thing, that here is a section for the feedback, and your feedback is very important to us. Use this link. So there is a link. You can click on this link and you can provide the whatever feedback you have. For example, today's class, how the class has gone, or anything that you want to say to me, you can provide your feedback here. Earlier it was anonymized, but I have removed this thing. I want to now because whenever sometimes when you provide a feedback, you want a answer. So if it is an anonymous, then it becomes very difficult for me to give you the answer, because sometimes you you expect something that, sir, these are things are happening. So it is a kind of communication channel where you can directly talk to me anytime. If you put anything over there, that would be available to me. There is also a very important part, participant. For example, here you can see that there is a pre-course survey, and the form is here. You just click this particular form, and you please provide some of the informations, so that we can set that what is your expectation, and we can tailor the course according to your your expectations, so that it becomes more fit to you. So two things that I wanted to request right now from you, that after this class you can just fill this pre-course survey, and uh, fill this feedback thing. If you wish, you can provide me anytime any feedback that you have about the evaluation component whenever they would be coming. So more information would be come on this particular tab. Click on the evaluation. Whenever the evaluation component would be on, you can find out the things related to that. There would be some lab session which are actually not planned into the original course, but we would be conducting various uh, lab sessions, so that you also get the hands-on feeling on all the things which are there. There is a student list, and I encourage you to find your name, that where is your name into this particular list. The people who are here, they would be sent the regular information about the course. Even if you are actually attending the course from auditing the course, if you wish, I can add your name over here. It is not just the peoples who are registered over here, but definitely the people who are registered, their name should be there inside this particular list. All right, so what we have understood that there is a course web page. On this web page you can visit and you can take advantage of all these things. Okay, one thing I think I should also mention at this worth mentioning at this particular point, that whenever there would be some evaluation component, you can check your marks. Okay, and then to check your marks you have to provide some username and password. This would be sent to you very soon, and this you can log in, and most probably it is not required right now. Whenever there would be at least one component is over, at that time you would be getting your password, and then you can log into this particular place and see that what are the things, how much marks you have got over there. Make sure that the marks which are here, they are actually kind of final. So if there is any discrepancy, please let me know so that I can correct them, and and you there is no confusion into that. All right, so in this particular session, as I mentioned you, that we are going to see the course logistics, that what are the things that are going to come into this particular course, and also we are going to see the introduction. The introduction is actually, I have put this because it is a first class. I want to keep you updated of everything. So and also, since there is no prerequisite for this particular course, so um, I would try to put everything from the zero. Let me also mention at this particular point of time only that you need not to have any baggage to attend my classes. So what happens, that let's assume that all the classes are happening one by one, and you somehow miss a particular class, and now you are thinking that I don't, since I have not I have missed that particular class, how can I attend the next class? Don't think like that, because there are so many topics that we have, and most of the classes are going to be of the independent nature. Only few classes would be there which are actually related, and whenever this kind of scenario is there, I would always try to put all the things that are related to the course into my material only. The course is going to be mathematical heavy, and course, because a lot of things are there that you need to understand to be good into this particular domain. So course could be mathematical heavy, but don't think that if you don't have any background, you should learn anything from outside. All the mathematical details that are needed from our course, I would be providing you the link for that, and I would be very briefly covering this also during the session, so that you are onto the same pace. If you are a good student, if you are decent student, if you are attending the classes regularly, you would not find anything that you need to read anything outside to be good into this particular course. This course is very demanding, as you know, that everybody nowadays talk about the deep learning and machine learning and artificial intelligence, and deep learning is a thing that is actually going to solve many of the promises that has been made to the society from very beginning when the computer were actually introduced. So that's why it is a mandate to cover many things, and to go deeper into the technologies, so that I can bring the sufficient interest for you into this particular course. So once again, welcome everybody to this particular course. This course is going to be very interesting, and I believe me that it is also one of my favorite courses that I teach over here, because every day when I teach, I also learn, because I have to work hard and I have to find out the new things which are happening into the domain, and by this we are going to learn. Let me start our discussion, and by just giving you just going to the very basics to the computer science, and let me ask this particular question: that do you know that what is a computer? Okay, let us start by this thing, that by just saying that very simple concrete thing, that what is a computer, because we are working with a computer, and and as a computer scientist, our focus is toward the computer. What is a computer? If you go on the Wikipedia and try to find out the definition of the computer, you are going to encounter this definition, which says computer is a device that can be instructed to carry out sequence of arithmetic and logical operations. So it is a very simple machine that can only do what? Arithmetic and logical instruction operations. So you provide sequence of instructions that are going to do something. What is that? 1 minute. That is going to do only arithmetic and logical operation. Um, such a simple machine. This machine can do miracles. So we have seen that people are talking about nowadays that these machines are going to be intelligent. Okay, uh, only by performing the arithmetic and logical operation, sometimes we expect that the machine is going to behave intelligently. What do I mean by intelligence? All these things we are going to discuss very soon, but let's think that it is going to be something very smart. We want the computer systems to be very smartly behaved. So if this machine somehow, if I, let's assume that I have some machine, some computer, and this computer is actually going to behave smartly, this computer is smart. So where is the intelligence? How come the intelligence has came? If the machine is behaving intelligence, where is the intelligence? Okay, how come this intelligence came to the computer? Because computer can only do the arithmetic and logical operations, sequence of arithmetical logical operation. How come the intelligence came to the computer? Definitely it has come because we have actually programmed in such a way. So it is coming to the computer because we have done the programming in such a way. So where is the intelligence? Whether the intelligence is inside the computer or it is because of the programmer. So you be saying, sir, this is coming because of the human who has actually, the programmer who has actually done this kind of thing. Uh, so if we talk about into more abstract way, we want the computers to be intelligent. What do I mean by this? That this thing that when the computer is making the when the humans are making the computer intelligent, we don't want this part. We want somehow the computer by itself should manifest in artificial intelligence. Intelligence. Okay, what do I mean by intelligence? Intelligence means you know that there are multiple things into the word. The system should try to understand that what these items are. For example, if you are there sitting and on a chair, so there is something called chair. If you are holding a pen, this is something called pen. So what does the, if I somebody says pen, how can and chair, how can I relate two different object to this? Pen is this and chair is this. How can I arrange, how can you find out this particular label? And you also know that sometime into the different kind of languages, the same thing. For example, if you say that chair is kursi in Hindi, so the same thing has different names. Okay, I'm not going to draw this because this is going to take time, but the same thing has a different names. So labels, first the system should able to understand that what are the different label, how the things, how they are labeled. He have some experience that how they are going to interact. For example, uh, if there is apple and if there is a human, so apple eats human. Sorry, human eats apple. Apple cannot eat human. So there is a relationship. For example, there is a relationship. For example, eat. So there is an apple and there is a human. So somebody can tell that a human can eat apple, not the apple can eat human. So not how the labels are interacted. What is the experience between them, and then the database of those interactions. Using these things, we actually develop our understanding of the word. So the system, the computer, it should also have, it should also utilize all these things, and somehow it have to do the processing. I'm just representing the brain here. It is no way needed. Somehow the computer is going to combine these things. Somehow the computer is going to combine all these things, and he can come up with something that he can write a program. Because ultimately, if when here we have seen that if some computer is going to behave intelligently, it is going to behave intelligently because there is some underlying there is some underlying program for that. So the computer should write a program. So it should write a program, and then this program can be executed on other machines. So if the computer can do this, then we say that the computer has an intelligence. Then we say the computer has an intelligence. Again, this is not the human intelligence, so we generally term it as a artificial intelligence, because this intelligence is not the human intelligence. It is coming from the computers. So our objective is that somehow the computer should be able to relate multiple things, and it should write a program. So if we try to analyze and try to understand that what is the intelligence mean into the very basic and concrete terms. So the intelligence is actually can be manifested by the human by into the three ways. When he performs some kind of task, few tasks could be the mundane task, those tasks which a person performs daily. These are the mundane tasks. Then comes the formal task, and then comes the expert task. These three kind of tasks the person performs, and we say that the person is an intelligent task. Mundane task involves something where you actually don't think that the person is going to have any kind of intelligence, but it requires some kind of intelligence. Let me give you an example. For example, when I'm telling something, you are listening, okay, and when I you are listening this, you are making sense that what I'm telling. So conversational systems, where there into the one language or the multi language or the mixed language, code mixed language. So different kind of conversational systems are actually such they are there in such a way so that even we don't think that there is any intelligence into the system. So those things, those operations comes into the mundane task. For example, if I ask you something, can you I want to go to this particular place, can you tell me that what is the path, what is the way, what is the map. So you can just instruct me, go into the straight, then take the right, take the left, and then you can tell me that what is the path to go from path A to B. So this requires whole lot of searching and the things, but you are not thinking that you are applying any kind of intelligence over there. Just think that somebody forgets about everything. Now he would not be able to tell you the path. So those things which actually comes to you very naturally, they comes into the mundane task. For example, when you wake up into the morning and you brush your teeth, this is also a mundane task. And doing this thing is not easy, because when you apply these things, just think about the mopping robots. They also need to do some kind of planning and operations. Formal tasks are those tasks that when you do, you think that you are actually doing some kind of intelligent task, such as chess playing, such as attending this particular class. When I'm teaching something, you are actually receiving that, you are thinking that, okay, I'm performing some intelligent task. If I give you a question, you are solving that question. At that time you'd be thinking that you are applying some kind of intelligence to that. So those things are the formal tasks. Expert tasks are something more concrete. For example, only architecture, only a uh, only the architectural person can design a building. Only a doctor can give you the prescription for the medicines. So those things comes into the expert task. These are the three categories of tasks. When they are performed, we say that these are the intelligent tasks. Now my question is that if the computer is intelligent, then he should also perform these kind of things. Okay, so we also want the computers to perform these kind of tasks. Let me ask you the question: which of these is more easy, whether doing mundane task or the formal task or expert task? What do you think that which is the most easy task? Can you type? Can anybody type? Whether doing the mundane task is easy in terms of the intelligence, or the expert, or the formal? Which is easy? Formal one? Formal one is easy? Somebody is telling formal one. Okay. You think that giving examination is easy as compared to that? Okay. So however, most of the time people say that mundane task is very easy because this comes to as it is. Okay. So we think that the mundane task is very easy. However, it is not like that. Doing expert task is very easy. However, in terms of the computers, as you have seen that from very, I think you may have heard about the robots that can do the operations. So operation, who can do the operation? Only the expert can do. So you have seen these system coming first. After that, you see that when we are mature enough, then we make these kind of system. And for these kind of tasks, even these days, people are not able to make them. So however it looks like that the mundane task is everyday task, then it is going to have the less intelligence, but actually it requires more intelligence as compared to the expert and formal things. There is a very important and subtle notion that is called the when can you say that this computer has artificial intelligence. Okay, there is very subtle notion that says that if there is a test that is called the Turing test, if the computer passes this test, then I would say that the computer has got the intelligence. Otherwise, I would say the computer has not got the intelligence. What is the Turing test? Turing test is has been proposed very long back. It is a very simple kind of test which says that let's assume that there are two rooms side by side, and a human is sitting at this particular place, and he is asking in one room there is a human, in one room there is a human, and in another room there is a computer. Nobody knows that in which room there is a computer, in which room there is a human. Now the task of this particular human interrogator is to find out this. So how would he would find out? He would try to interact with this particular system. So he can interact with this system. How he cannot see inside, but he can interact with these particular boxes. And if he, by doing the lot of interaction, if this person, if this interrogator fails, that he is not able to tell in which room there is a computer or and in which room there is a human, then this particular machine, which machine, this machine which was actually integrated over here actually passes the Turing test. You can see that this kind of test cannot be repeated, because if there is some test on which the computer has passed the Turing test, if you ask those questions to any other computer, so maybe even the computer did not have those kind of capability, but it can also learn the answer and then he can be passed on that. So this test is not a test which can be prescribed. So it is a kind of again very difficult to tell that which kind of question the person need to ask. So this is called the Turing test. If the computer would pass this Turing test, then we would say that we are into the arena of artificial intelligence. However, please try to understand this thing that a computer cannot do everything, because how can I make this thing? How would you think that I want to make this computer pass the Turing test? How would you go ahead? You put more power to this particular system so that it can do multiple things. Okay, you put more power so that it becomes enough powerful so that it can beat this. It can be at least equal to the performance of the humans, or it could be better to the humans. So, however, by putting more power to this computer is not going to work. Why? Because we know that there are many tasks, there are many tasks which even computers cannot do. Okay, you have seen one example. Everybody may have heard about called the something called the halting problem. Halting problem. If you ask from the computer, can you solve this particular problem? He cannot. Computer cannot solve this particular problem. So we have limited thing that we can push inside this computer. Try to understand this particular part. If you want to make this computer very smart, you cannot put infinite amount of power to this particular system. You have only limited things that you can do with the systems. So we have got enough understanding that what is the artificial intelligence. Let me tell you that where it stands. Okay, so you know that into the computer science domain there are multiple things that we do. Out of them, there is one area that actually try to develop these intelligence kind of systems. This particular place, this particular part is called the AI. So we may be doing AI, but into the computer science we do multiple other things also, that they are not related to developing the artificial intelligence. But there is one area of the computer science that actually deals with the artificial intelligence. To get the artificial intelligence, we can do multiple things. Out of them, there is one area that actually does the machine learning. Okay, for example, search is also there. And here into the computer science, for example, if we want to sort the number of a very big list, so sorting is there. Cryptography, all these things we want to do into the computer science, but they may not be related to the artificial intelligence. But into the but For example, if we want to develop the artificial intelligence based system, search can also be something that we want to do. It does not come to the machine learning. What is machine learning? Machine learning is another part of this particular artificial intelligence, where my algorithm are going to self learn. My algorithm are going to self learn. They are learning by themselves. Automated learning is there. So there are few methods. For example, the parameter discovery and such as you know that gradient descent based methods that are there. So automatic kind of learning should be there into the machine learning domain. And in this machine learning domain, there is another subdomain that actually uses neural network. Neural network. If you want to do the machine learning using neural network, then this particular thing is called the deep learning. This particular part is called the deep learning. So you can see that the deep learning, that is our course matter that we are going to study over there, is actually based on the neural networks, that how the neural networks are going to work and how we can make the system of that particular kind. And you know that neural network are actually inspired by the way our human neuron based systems are there, so we want to build a system like that. uh, you know that the computers are used to solve multiple problems, and they, for example, as I mentioned over here, sorting and multiple things that we use the computer to solve. For example, sorting, determine the existence of the Hamiltonian circuit, and Euler walk in a graph. So multiple things we want to do, but sometime some problems comes to us that is very difficult to define, and sometimes we don't know that how precisely we solve these things. For example, if there is a cat into the figure, if I show you a figure and ask that if there is a cat inside this, which cat could be of the different kind, whether it is a brown cat or white cat, or what kind of cat it is. Another question could be what is written onto the board. For example, there is a board. If I write something like this, you can say that it is nothing is written onto the board. If I write something, for example, if I have a board and if I write something like this, whether it is written something, somebody can tell that no sir, nothing is written on the board. But sometimes you can say that no, something is written, maybe some different language. I don't know that. If you don't know the language, something is written on the board, you can say that it is nothing is written on the board. So again, it becomes a very difficult question to answer. Which language it is in? Again, it is a difficult kind of problem. How to solve those things? How to ask help from the foreigner? Okay. So these kind of problem, either we don't know that how to solve them, or it is very difficult to specify the solution procedure. If these kind of scenarios we are in, then we go for the machine learning to solve these kind of problems. So very historically, in around 1956, there was a professor, Arthur Samuel, who actually wanted to design a check, uh, checkers playing program that can beat him. So he was thinking that the basic idea was actually very interesting. He was thinking that why should I write a program and give it to the computers to learn? Why not the computer by itself generate various different board positions and learn that what is the best for him to win this particular match? Because computer can enumerate enormous number of such possibilities, and they can have a the knowledge in a very effective way. So around 1962, he was able to make that particular computer, that particular system, which by automatically was able to learn, and then this particular system actually won over the human player. That's why Arthur Samuel is called the father of machine learning. So into the machine learning domain, our objective is that we want to improve the performance. Our objective is that we want to improve the performance using some kind of experience. So there could be some kind of experience that is coming to us. Okay, experience means playing the same game multiple number of times. Various kind of learning systems has been defined. So if you want, the computers should automatically learn the thing. So these names you may have heard. So, for example, supervised learning, unsupervised learning, semi-supervised learning. What do they mean? Supervised learning means when I want to teach the system, I'm going to give the example, where for some of the example that I'm going to give, I'm going to tell that what is the right answer for them. Okay. So if I specify the right answers, so who is going to specify? Let me tell that there is some teacher who is going to specify that what is the right answer. So when the system learns using this kind of example, where for every data item right answers are also provided by the teacher, then this system is called the supervised learning. Here we say that it has a multiple applications, where for example, if you want to classify something, various classifier are actually coming to this particular category. Then comes another category of the problem, that is called the unsupervised one. It is into the unsupervised setting, what happens? That right answer are not provided. Into the unsupervised setting, right answers are not provided. The computer try to make sense of the data, because if the data is given to you and these right answers are not given, then the computer try to understand that what are the different categories of the data items which are there, and then use this thing to explain you something about the data. So for example, clustering and the association rule mining, these things actually come into this particular category. In between these two extremes, supervised and unsupervised, there comes a semi-supervised version, where the right answer for some of the things are actually given, and for the remaining the right answers are not given. Another category of the problem is the active learning, where this is a very interesting kind of idea, where the system can ask who is the system. The For example, if I you have an example and you want to train a model, this model can ask the question for some of the things. Okay, this question can ask that give me the right label for this particular item. So it is something like that. For example, if this is a your area where these are the one kind of item, this is the next kind of item. If I ask you that can you give me a classifier this, so this is a very simple kind. This is problem. This is not a very difficult problem, because you can see that you can draw a single line over here and find out that uh, what is the classifier. But if I give you, what if I give you the right answer for these things only? Would it be the right thing? Because if I give you the right level for these items only, so you can, where can you draw the line? You can draw the line here, here, everywhere you can draw the line. All those lines would be, uh, you can think that they are right based on your data. But if the two categories of the data is there, then your lines would be here. You cannot draw the line if the examples are given over here. If I ask you, if I allow you that you by yourself can ask the question, then definitely you would be asking me, sir, can you tell me that what is the label of this particular item? So if I tell you this label, maybe I can say that look, they are the positive item. Then you would ask me that what the label for this particular item. You would not ask the items which are actually nearby, because you are most confused about this item only. You see that these items are nearby to me, so looks like they are similar, but this item is far away. So you would ask that what is the label for this particular item. If I say that this item is negative item, then definitely you can immediately draw this particular line. To be more sure, then you can see that looks like that I have more confusion on this particular item. You would ask that what is the label of this particular item. If the answer is provided as minus, then this is the good answer. So only using the examples, two trainable examples, you can come up with a line. But if I give you 100 such examples, and which are actually only one side, they are actually going to only confuse you. Okay, so this is a very interesting idea, where active learning, it is called the active learning, where you can ask the question. Then comes the lazy learning. It is again a very interesting idea that tells that don't perform any operation until somebody asks you the question. If I teach you something and don't take the exam, you need not to read. Okay, because you are passed. So if lazy learner does not do anything until some answer is going to be asked from him, so at the later point of time when he sees that some need is arrived, then only do the consolidation and learn the things. Reinforcement learning is very interesting idea. Actually, this is the core of the machine learning concept. It actually says that you by yourself try that what is going to happen. Multiple things you have to try, hit and trial. So it by itself design multiple experiments and does those experiments and interact with the environment, and by this particular system going to learn something. Another interesting kind of learning approach is the transfer learning, where one system, maybe for example, if you want to run something on your Apple Watch, so Apple Watch may not be having a lot of computation capacity to develop anything for him on its own hardware. So what you can do, you can develop those things on the another machine, for example on the bigger server, and when the thing is developed on there, you can port this to the Apple Watch, or any kind of watch that you have. So on the high capacity machines, you develop something that is going to be used onto the smaller capacity machines. So this is going to be the transfer learning. And then comes the deep learning, that is actually a subject matter of our course. Here we do the processing like the human brain. We want to deploy our model in such a way that as the things are connected in my brain, how to connect them, what is the advantage between with respect to each of them, this is going to be the subject matter of our class. Whenever you develop a system, okay, whenever you develop a system, we call it model. Okay, whenever we develop a system, we call it model. So you want to understand that how good this particular model is. So various matrices are there, such as you can say that what is its accuracy, what is correct recognition rate, equal error rate. All these things are actually important metrics that are going to be utilized by you. We would come back to these things in a few next few classes. Another, how do I choose a model? Various models are there. For example, decision tree, SVM, neural network, various things are there. How to choose this particular model? Again, you need the domain knowledge and the kind of problem that you have. So you actually go to this kind of answers. Next question: do I have the enough data? If you don't have the enough data, how can you train? Next question is the data of the sufficient quality? If the good data is there, you can build a good system. If the good data is not there, then your system can get confused. Okay, how confidence I have on my result? If for example, my model is going to give me that yes or no kind of answer. If it is going to give me yes, should I utilize this for me or not? Because sometime it may be possible the system is going to say that go ahead with this particular thing. But if I see the probability is 0.51, should I go ahead? It becomes very difficult because the another item has definitely is going to have the probability of 0.49. So if the one thing is going to have the probability 0.51 and another has a 0.49, so going to S is actually not important, may not be that a good idea. So you have to understand that what is the significance and the probability of this result. Only going just seeing the yes or no may not be the sufficient for you. Am I describing the data correctly? You have the data, you want to describe this data, whether my system is going to describe the data correctly, whether my system is fair or not. This is again a very important question. Fairness means what? For example, if you want to develop a face recognition system, okay, you want to develop a face recognition system, and you have used for example all the uh, Chinese people. So you have taken the data from the Chinese faces and you have developed this particular model. And let's assume that somebody from Africa comes here. So you know that the complexion of the African peoples uh, are darker. So if those kind of peoples the system has not already seen, if the person comes in front of him, so maybe the system is going to have the lower accuracy as compared to the peoples who are going to be coming from the fair complexions. So this is not a good thing. Okay, so our system we should make our system in such a way so that it should be fair to the all the peoples. Not it should be it is good on one group of peoples and not good for the another other people. This is not a good idea. Try to understand that. What do I mean by fairness? That for all different sections of the peoples, the system should be able to perform into the with the same accuracy. This is a very interesting diagram, and this is a very fundamental diagram also. For example, if I give you that some data that you train your system on this particular data, okay, I give you some data. So definitely you would, since only this data is available, you are going to train your thing on this. This is the training part and testing part. You divide the another part for the testing. The next part you put it for the testing. Why you are going to put the testing? Because on the unseen things you want to see that what is the accuracy of this particular system. So mostly you split the data in such a way that 80% data is here, 20% data is here. So training and testing partition you have to apply so that whenever you develop something you can test immediately because some test data is also there. So let me show this particular place that says that one side I am going to have the training error, another side I am going to put the testing error. Okay, so training means the error on this particular part. Testing means error on this second part which had not been shown to the system. So initially what would happen if you start the system, you would be somewhere here because uh, let me say that this is the high part, this is the low part, this is the high part, this is the low part. So what you want the lower error into the training and testing both. You want to be here, but when you would start, you would be here. Your training error is also high and testing error would also be high. Initially you would be here. Okay, but nobody want to be here. You want to change something. Where you want to come? You want to come here. Let me ask you this question: if you come somehow here, is it a good idea? Yes, it is also a good idea because whenever you are going to develop a system, you are going to develop the system for the unseen things. If the something is good on the unseen thing, because here the low error on the unseen thing is there, so this is a better place. But the problem is that you don't know that how to come over here, because if you come from up to down, it means that your training error is not reducing, So whatever you are going to change your parameter, you are going to change your parameter based on training only. And since your training error is not going to reduce, it means what? That you are not going to change your parameter, means you are not going to progress in this particular direction. You would never come into this particular direction because you are not going to change your parameter, because your training error is not reducing. So what is the objective? Somehow you have to come into this particular direction. So two direction could be there. Either you go upside or you can go downside. It may be possible that you are here, but you are changing your parameter in such a way that you go into this particular direction. This particular direction is also possible. Here, if you go into this particular, please note that if you go into this particular direction, so ultimately what is going to happen, that your training error is reducing. Testing error is actually going up. This is a problem. So that's why we need a validation set to know that whether I'm going up or down. So this sometime what happens, that's why sometimes what happens, that when you have a database, as I told you, that you are going to put 80% of the for the training and 20% for the testing. Sometimes you say that out of this 80%, 20% I'm going to keep for the validation and 60% I'm going to use for the testing. So validation makes you decide, gives you this idea that actually my accuracy is going to, my system is going to into this particular direction. So you should go into this particular direction. Okay. So using validation, you can actually remove that particular part. Now the question comes that there could be different kind of slopes. So different kind of slopes are possible. If you are into this particular thing, for example, then you would be reducing the training error, but you are not reducing the testing error. This thing is called the overfitting kind of condition. Here you are going to be overfitting. This is the best one, and these kind of curves could be better one. If you use your validation set wisely, then you would be reaching to this particular thing. That is the best choice. However, if you are not using this, you would be using here. That is the third choice for you. Make sense? Any questions on that? Sometimes people can ask that, can you give me the best model, best machine learning model? The answer is no. Answer is no, because if, for example, you have a model, maybe a neural network or whatever, XYZ kind of model, if there is a data A on this, it has accuracy, for example, 60%, and there is a data B on which, so I can always say, let me say that on this, let's assume that you have a database A on which your accuracy is 90%. I can always come with another set of database that is carefully selected. The places where there is, for example, if it is accuracy 90% means what? 10% of the examples would be there where there is a problem. I can put this 10% and create another database and ask you to train on this. Definitely your accuracy will be very bad. Okay. So carefully selected example can always bring you down. Okay. So there could not be a single model that works best for all the databases. However, word is structured, and we know that a specific kind of databases are only going to come to you, and that's why in most of the cases you are going to have the very high accuracy, and for some of the cases you have the bad accuracy. This kind of scenario is possible. So the best machine learning model, there is no notion of like that, but we know that in most of the cases my system is going to be perform better. This is another very important slide that actually tells you that most of the time we actually focus on the machine learning part, and we think that only machine learning part is ML or DL part is very important. All other things which are actually related to the deployment are not related. If we work enough on this, we can solve this particular problem. But actually it is not like that. Even if you develop something that is going to be machine learning, a very good machine learning code, you have to deploy so that it can be used. And when you deploy, when you go for the deployment, this kind of scenario actually arises. Your machine learning part, which is actually the settled part, becomes very small, and other things becomes very important for you. So most of the area, for example, you can see here, you can see that the 50% area was covered by the DL. You think in this particular way, but actually it is not like that. Other things are also becomes very important into the ML domain when you go for the deployment. Uh, Let us talk something about the deep learning, and you know that the deep learning is uh, is has actually evolved around 2012, when AlexNet actually have actually solved a very important long-standing problem of the imageness classification. Okay, so there is a very large database of the images, and the people want to get the very good accuracy on that. So before 2012, people were using the handcrafted methods. So these slides we would again come back to into the later classes. So what happens that at that time people were using handcrafted methods such as histogram of gradient, linear binary pattern, SVM, etc. And there they were actually on this particular database, their error was at 28% or 26%. But suddenly in 2012, AlexNet actually have introduced a deep learning architecture, and that has reduced the error from 26 to 16%. Next year, the ZFnet, which was the improvement on the same architecture, actually had reduced further and told that AlexNet can be organized better to give only 12% error. Next year the error becomes 7.3% with the VJG and GoogleNet and ResNet. They have actually reduced this particular error to 3.6%. So you can see that the system which actually was actually for a very long was not able to deliver, suddenly when the deep learning came, actually started delivering the things to the community. That's why we have a lot of interest into this particular domain, and we want to one by one see all these architectures and try to learn from them. This database is not that easy, and even humans have this 5% of the error. So any system that is going to be do lesser error than the human, they may not be that much significant. Why these systems were able to deliver something? The reason is that our human brain, our system, our human vision system is also kind of hierarchical, and these kind of system try to build the hierarchical feature. For example, uh, when some object is there in front of your eyes take V1 feature, then combine them to the V2 feature, then combine them to the V4 IT posterior and IT anterior. So different kind of hierarchy are the feature they construct, and by seeing this kind of digits they actually come up with the understanding that what are the things over there. This is a very interesting diagram which actually gives the same idea that let's assume that this is the error. So initially it try to understand that what are the different kind of color, then combine how these colors are combined, then what are the different kind of parts here, then how can we combine those parts to the single object, and then using this single object you can tell that whether there is a car, person or animal. So hierarchy or feature is actually the important idea. So if we can have more number of layers, these things are called layers. If we can have the more number of layers, then we can come up with a better kind of features, and they can be very automatically trained. All these things would come, once again let me tell you that all these things come with the more detail into the later classes. There is no area where the DL and machine learning cannot be applied. Everywhere we can apply we can apply machine learning, deep learning, spam filtering, stock market analysis. Everywhere we can apply all these things. Let me give you some success stories that actually has been done earlier. Very recently, we have seen AlphaFold 2 that has solved in that this came in the November 2020, and it actually given some kind of amino acid sequences, gives you the 3D diagram of that particular amino acid. So using these things, we can very easily do the analysis and tell more things about that. You can just see that for very long period of time, this particular graph says for a very long period of time, the accuracy was around 60%, but into this particular small span of the time, the accuracy now has become 90%. So wonderful algorithm that increased this particular accuracy to the 90%. You have seen the this thing that Deep Blue was a computer that was actually was able to defeat the Gary Kasparov, who was the world champion and into the chess. You know that the match was won by the Gary Kasparov, but after that he only loses three successive ones and was into the draw for the next one. AlphaGo was another example that came very recently in 2016. It was able to defeat Lee Saddle, who was the world very high uh, Lee Alpha Go player with a 4-1. Uh, Another thing is that Waymo, you know that this is the company that actually wanted to give you the ride to the peoples, and it's a taxi service, and they have actually given in 2015 they had given a ride to the soul blind person. Very coming soon it is going to be with you. German traffic sign recognition benchmark database, old database. Now we have the accuracy of 99.46 add against to the 98.48% that is of the human. So we are better than human, slowly becoming better than the human. This is the images taken from the doorsteps. People are writing their house number, and within 2 hours the system was able to classify all these things which are actually given into the France street of the all the streets of the France. This data was actually converted. Image search has come to the long domain. You can see that if I search this particular image from to the internet using a search engine called Japanese search engine Baidu, so it has given these kind of images. If you compare these images, you can find out that everywhere there is a similar kind of background. Everywhere the elephant is actually seeing in front of this. So all these things has been taken care by this system. This is another thing that tells that image, and the system was able to provide the description that what is over there. System are nowadays able to provide the descriptions. Tissues, the person can do, the system can do the segmentation. Here you can see that these are the tissues, and doing the segmentation for by the human was very difficult, but the computer system, automated system has a very high accuracy. Neural segmentation, neural based segmentation, neural network segmentation, all these things look similar, but they have very high accuracy. Here into the medical domain, the person comes to the physician, in the system, the computer system interviews the person and asks that what kind of problem you have, looks to the database, find out the person having the same kind of problem, and provide the prescription that was most effective to given to those kind of peoples which this kind of problems have. Now the doctor can take the call and tell that what kind of medicine you can take. Only using these four kind of capacities: reading and writing, speaking and listening, looking at the thing, integrating the knowledge, the system, most of the thing means 80% of the task that the human can do, the computer can do all those things. 80% of the task that the human do. We have seen that the human capabilities of the human is also increasing, but the capability of machine is going to increase exponentially. We are right now at this particular place. Very soon we would cross this particular line, and the machine can be better than the humans, as opposed to the industrial revolution, which actually started and after that it saturated. The machine learning is not going to be saturated. It is going to be because better and better, because better system is going to more better system, and we are going to see exponential growth into this particular area. Lot of things has been done into this thing, and in our course we are going to see multiple of them. For example, we are going to see neural network, perceptron, neural networks, back propagation optimization, hyperparameter tuning, RNN, transformers, GANs, RBM, autoencoders, LSTM, YOLO, multiple things we are going to see into this particular domain. All the latest things we are going to cover with the full detail that is possible for us. This is the thing that we are going to see our what are the different components. As I told you that this course is going to be heavy, because it should be heavy, otherwise it would lose its importance into this particular domain. A lot of experiments, a lot of progress has been done that I have to bring in front of you. There will be two assignment, one on the latex and another on the programming assignment, that would be related to the lab, and it is going to have the 15% component. There will be some class project where you would be collecting the data, running the model, and writing a report, and it is going to be up to 15%. We are going to have the mid-semester test of 25%. Term project, that is going to be latest, that is going to give you the latest information about the what is happening into the research domain right now. It is going to be related to the paper presentation, 10% thing. Comprehensive examination, it is going to be 35% weightage. Comprehensive examination, as you know, is scheduled on May 13. There would be lab. You have to attend all of those labs. However, they are not going to be evaluative. One problem would be given to you that you can utilize and solve something for your assignment. Our goal is that you should be able to apply these things, understand and apply this thing in your area with a full detail. Okay. Please note that whenever any assignment or any things is given to you, it is supposed to be written independently. You have to solve all those things independently, and if only if there's something is defined that you can take the help, you should take the help. Otherwise, you please solve it by yourself. That's all for today. Thank you very much. Please ask the question or you suggest me anything that you is in your mind. Thank you once again. Thank you very much. Any questions?
So what would be the timings of the lab?
Assignment of the lab?
The timing, the schedule.
Okay. So right now it has not been decided. Most probably it would be on Saturday. It could be of the 2 hour durations when you have the time, and because something need to be explained to you, and with the full experimental details, maybe of the 2 hour duration. Right now, it is not been cleared, decided, because the TAs are not being right now assigned. So when the TAs would be there, with the help of them, we can come up with a better schedule. Definitely, you can suggest me that what should be the better schedule. We can take care of that also.
So for term project, will we be provided research paper, or we are free to select any research paper we want?
You are also free to select any paper for your side. However, we would also be providing you a list, and most probably those list many other people follow, because we come up with the good titles where there is a implementation and everything is available. If you find anything, you can also come up with yours. Okay,
Okay.
but it should be of sufficient interest. Yeah, it should be good thing, because coming into this particular thing, it should not be a escape route. You have to find out the good paper only, so that everybody is interested and learning happens over there.
And for the class project, data needs to be like data set. We will be creating, or like we can use open source data set?
No, no, no. Open source data is not needed. You have to collect the data. And this last time we have actually used a Android application to collect the data, but this time let me try to figure out. So somehow some kind of data, some kind of interesting problem you can come up, for which you collect data by yourself, so that you get a full understanding, that full pipeline understanding, that what are the things actually people do when they solve these kind of problems. So you have to collect the data, you have to curate it, you have to do some kind of thing. So last time what was happening, that we have picked a particular problem and everybody participated. They have collected the data at their end. So only, for example, if you solve the plant leaf classification problem, everybody is going to collect the data of 20 plants only, because many plants would be there. So if 100 people collecting the data of 20 plants, it becomes 20 100 data, means 2000 data. And now this data is given to you, everybody run on your model on that and get the accuracy. So this is the general model where you collect the data, everybody gets that particular data and runs on that. However, I have not thought that what kind of data I would give you, but let me think about that. So data you would be collecting, on your data you would be working. Most of the time what happens, if you go and try to see any data that is already available into the Kaggle and other kind of sources, many of the already available models are already there. So sometimes they raise the bar. Their accuracy is 80%. Uh, Achieving that accuracy sometimes becomes difficult for you. So you by yourself collect the data, that any problem that is actually of your interest, you can collect that data, you can work on that, and we can go ahead with that.
Okay, thank you, sir.
So which framework are we going to use for programming?
Python, mostly Python.
No, in Python, like which
TensorFlow,
framework
TensorFlow, or
or
any other
PyTorch?
things. Yeah,
Anything
mm,
is fine.
anything you can use. Yeah, no problem.
Okay, thank you.
Labs would be into the Python and TensorFlow and PyTorch. So that we are going to see.
Both of them.
No, both of them would be not be there. So this depends upon the. I think PyTorch is better than the TensorFlow. So
Py
and easy also. PyTorch is most probably would be there.
Okay, thank you.
Hope you enjoyed this lecture. This lecture would be available on the YouTube, and you can see this at any time. So the link would be again available on the same website. Thank you, everybody. Join all the sessions. I welcome all of you once again from my side. Any comments on the weightage that you think that should be adjusted, or anything else?
No, sir, it's all right.
Thank you very much. Thank you all.
Thank you.